All right, today we're going to talk about finding functions given zeros. So this is very similar to what we had done the other day when we're finding equations given zeros, but this is going to be just slightly different. These now will be y equals and not 0 equals. So there's the first big difference. So let's take a look at what we had done previously. Find a quadratic function whose zeros are 4 and 6. So once again, we'd start by saying x equals 4, x equals 6, and then we'd go ahead and subtract those and make an equation. Before we would say 0 equals, and all of those coefficients had to be relatively prime. But now we're going to say y equals, and if we had done it before, we would have had this particular equation, x squared minus 10x plus 24. But it could have actually been any of these equations because we were assuming that the a value was 1. That's kind of what it means when it says that they are relatively prime, that the a value is 1. So now on doing these, we're actually going to be giving you a point and you're going to find the actual equation or finding the a value. There's also another way to find the equation. This is just kind of an aside. You don't have to do it this way, but I just wanted to mention it, that if you said find a quadratic whose function whose zeros are 4 and 6, we know that when we have a quadratic function, it has a certain pattern where we know that the sum of the two numbers is the middle term, and then the product of the two numbers is the last term. So you could use the sum and the product to kind of go right to writing the equation. So that's just a little bit of a quicker way. I don't know if it saves you much time, but it's just kind of a comment that you might want to think about. And still, it could be any one of these because the first one would be relatively prime and the other two are not. So right now we're saying if you're asked for a function, then you're going to give the one in which the coefficients are relatively prime integers because you can't find the a value because you need more information. But if you are given another point of that function, then you're going to use it to determine a very specific function, or you're going to use it to find the a value. So that's kind of the two differences. If I give you a point, then you know you have to find the a value. If I don't give you a point, then you cannot find the a value, and you'll just assume it's 1. All right, so here's an example. The zeros of a quadratic function are 2 and 7. That's just like we had done the other day. But now I'm giving you more information. F of 1 equals negative 18. Find the function. So remember, f of 1 equals negative 18 is just telling you when x is 1, y is negative 18, or it's giving you the ordered pair 1, negative 18. So you're going to start just like you would always do. You're going to write the equation. But now again, instead of writing it as 0, I'm going to write it as y or f of x. And I'm going to now put an a value in there. Now I can use this information. I know when x is 1, y is negative 18. So I can plug that into this equation, and the only variable I'll have left is a. So I plug that in, I simplify my equation, and I solve for a. So now I know that this is the specific equation that they're talking about, and now I can just multiply it out, and I have the actual function that they're asking me for. Let's try another one. The zeros of a cubic function are 4 and 3 plus or minus the square root of 3. Find a function such that f of 2 equals 8. Again, you know you have to find the a value because they're giving you a point. They're giving you the point 2, 8. So you're going to start like you always do. You're going to say x equals 4, x equals 3 plus or minus the square root of 3. Then you're going to simplify those until you have your equation. And you know that 3 plus or minus the square root of 3 will end up being x squared minus 6x plus 6. So then here is going to be your whole function. Remember, you have to put the a in there now. And then you're going to use this point 2, 8 by plugging in 2 for x and 8 for y, and then solving for your a value. And now you know a is 2. So now you're going to plug that 2 in, and you're going to multiply this all out. And there now you have your function that they had asked you for. All right, the zeros of a third degree function are 2 and 1 plus or minus 3i, and p of 4 is 12. But now they're not asking you to find the function, they're asking you to find p of 8. So this is yet another way that we could ask the question. And this way is actually a little simpler because you don't have to multiply out that whole polynomial. So you start like you always do, you find what the function is, you put your a value in because they gave you a point. You use that point to find the a value. And so now you know you have this equation here, but instead of having x's here, I'm going to say, well, they want me to find out what p of 8 is. So everywhere I would have put an x, I'm going to put an 8. And that makes it easier because I don't have to multiply this whole polynomial out. I can just simplify this expression. And I know p of 8 is 116. So when they ask you to find p of 8 or p of 2 or whatever it is, you're just going to plug that value into the equation and you will get a number. All right, this is an interesting one. It says p of 4 equals p of 2 equals p of negative 2 equals p of negative 3 equals 0. So think about what that's telling you. That's telling you that 4, 2, negative 2, and negative 3 all are on the x-axis, or all are x-intercepts, because y has to equal 0 at that point. And then they're telling you that p of 0 is 32, so then they're giving you a point. So you can start by writing your equation. Oh, and then they ask you to find p of negative 1. So you can start by writing your equation. If these are all intercepts, you know it's going to be x minus 4, x minus 2, x plus 2, and x plus 3. They're giving you a point, so you're going to put your a value in. Then you're going to use that point to find your a value. Simplify this, and you know a is 2/3. So once again, they didn't ask you for the equation, they asked you to find p of 1. So you're going to go back to your equation, this one here. You're going to put the 2/3 in for a, and you're going to take this negative 1 and put it in for every x. And then you're going to simplify this. And now you know that p of negative 1 equals 20. All right. P of x is a 6th degree polynomial. The zeros are 2, negative 3, and 1 plus or minus 4i. So right away you notice they've given you 1, 2, they've only given you 4 zeros, yet they tell you it's a 6th degree function. But then they go on and tell you the graph is tangent to the x-axis at 2 and negative 3. So remember, if it's tangent to the x-axis, that means it creates a bounce, what we call a bounce, which means that 2 and 3 are going to be a root an even number of times. In this case, it has to be twice. So that's how I get up to my six roots, which is what I need. Then it gives you p of 0 is 102, so it gives me a point, so I know I'm going to have to find my a value. And then it asks me to find p of negative 1. So once again, you're going to start by writing out your equation, but now I'm going to say x minus 2, but I have to square it because I know 2 is a bounce. I know 2 is a root twice. And here, the negative 3, I'm going to say x plus 3. Remember, if negative 3 is a root, x plus 3 is a factor. If 2 is a root, x minus 2 is a factor. That's an important thing to recognize. And then I just took the 1 plus or minus 4i and kind of worked backwards and got the equation for that, or the expression for that. And then I put my a value here. Now I'm going to use this point, p of 0 is 102, in order to find my a value by plugging it in and simplifying and solving for a. So now I know that I'm going to go back to this equation. I'm going to put my 1/6 in for a, and I'm going to put this negative 1 here for all my x's, and I'm going to simplify this. And so I get p of negative 1 is 120.